Hello, my lovelies. It's Susanna, and today I want to show you how to solve this problem. The figure consists of 4 semicircles that seamlessly connect to one another. Let's take a look at these 4 semicircles here. We have this big one here. Then this connects to this semicircle. Then we have this tiny one here, and the 4th here then. The largest and the smallest semicircle share a common center. So the largest semicircle, this one, and the smallest, this one, they share a common center. So if I want to draw this center here, let's call this M, then M is the center of this smallest semicircle and of this largest semicircle. What is the area of the red shaded region? So we want to find the area of this red region here. Let's call this area A, and how can we find it? Maybe we divide our area into 2 parts, this part down here and this part up here. Let's maybe start with this part down here. How can I find the area of this region here? Well, it consists of this largest semicircle, but this area would be too much because we are only interested in this red area here. So we would have to subtract the area of this semicircle here. That is green now. It was white before, but now this is our green semicircle. Maybe let's call the area of this largest semicircle A1 and the area of this green semicircle A2. Then we find this red area here by taking A1, which would be too much, and then we have to subtract this green area here, so we have to subtract A2. Okay, then we want to add this part up here, so how can we find this area now? This consists of this semicircle, which would be too much again. So we would have to subtract this small semicircle here. So let's call the area of this semicircle A3 and the area of the smallest semicircle A4. Then we find this red area up here by taking A3 and subtracting this small semicircle A4. This is our plan. We only have to find A1, A2, A3, and A4 to find our area in the end. So let's start with A1. How can we find A1, the area of this largest semicircle? Well, there is a formula for the area of a full circle, which is pi times the radius squared. But here we are not interested in a full circle. We only need a semicircle. So we take this formula here and divide it by 2 because we only have half of a circle. So we need the radius to find the area of our semicircle. What is the radius of this largest semicircle? The radius always goes from the center, so this is the center of our largest semicircle, from the center to the edge of this semicircle. So this here is my radius. Maybe let's call this radius A. And then I just take the formula. I have pi times my radius here is called A. I square it, and then I divide it by 2. This is my area A1. Okay, what about A2 then? The area of this white semicircle. We still have our formula. We just need the radius of this white semicircle. But we don't know where the center of this circle is. So maybe instead of working with the radius, we could also work with the diameter here of this white semicircle. What do we know about the diameter? Well, here on the right side, we had from M to the edge here, this was the radius of this largest circle. So also on the other side here, from the edge to this center, this is also the radius. So I have my A here on the left side as well, which is a part of this green diameter already. I just have another part here from the center to this edge of this tiny semicircle. Let's call this part B maybe. We don't know yet how long B is, but we know that it is the radius of this tiny semicircle because it goes from the center here to the edge. Okay, so now we can say that the diameter D is A plus B. So we know this is our diameter. But we were interested in the radius, so how can we find the radius now? Well, we can just take the diameter and divide it by 2. This is then our radius. Doesn't look very pretty, but let's take this as our radius. So we have pi times, instead of the radius, we take this beautiful fraction here. Then don't forget to square this. So write it in parentheses and square it. And then also divide it by 2. This is our area A2. Okay, what about A3? The area here of this semicircle. Same thing here. We don't know where the center of this semicircle is, but we can work with the diameter again. What do we know about the diameter here? Well, A is already a part of the diameter. And here, what about this part here on the left side? This is again the radius of this tiny semicircle from the center to the edge, which is our B. So we have B here, which means that our diameter here is B plus A. And again, we were not interested in the diameter actually for our formula. We need the radius. But we can find the radius by just taking the diameter again and divide it by 2. So this is not my diameter, this is my radius then. So for our formula, we have pi times, instead of the radius, we have B plus A over 2. Don't forget to square this radius and divide all of this by 2 again. Okay, we keep in mind this is our A3. We still need to find A4, the area of this tiny semicircle here. But we know the radius of this semicircle because this is just our B. So we have pi times, our radius is B, so we have B squared and divided by 2. So now we have A1, A2, A3, and A4. We go back to our plan we had for our A. I inserted all the formulas we've just found already here for A1 to A4. And now let's simplify this a little bit. We have pi times A squared over 2 here. Okay, we cannot do anything here. But what about these two? If we take a look at these two, they look pretty similar. We have minus here and a plus here. We have this over 2 in both cases. We have the pi, we have the pi, we have the square, we have the square. Here inside we have A plus B, and here we have B plus A, which is the same. And then we divide it by 2 as well. These two expressions are the same. We have a minus here in front of it, a plus here in front of it, so these two expressions equal 0. in total, so we don't need them, which is great. And then we still have this other part here at the end, which looks like this. Okay, now we want to subtract two fractions. We already have the same denominator, which is great, so we can just take this denominator and subtract the numerators. So we have pi times a squared minus, and here we have pi times b squared. Okay, now pi is in here and in here, so we could factor out pi. Let's do this so that we have our fraction here. And if we factor out this green pi, what is left in my parentheses then? We have this minus here in between, and if we factor out pi, only a squared is left here. And if we factor out pi here, only my b squared is left. Okay, this is our area now. We know pi divided by 2 is also not a problem, but what is a squared minus b squared? We don't know anything about this yet. So let's go back to the beginning and let's try to find a squared minus b squared, because have you noticed that we haven't used this information here yet at all? So the length of this part here is given by 4, and we have a right angle here. And we want to find a squared minus b squared. A right angle always reminds me of the Pythagorean theorem if we have a right triangle somewhere. So maybe from the center here to this point here, let's create a right triangle here. And we know this length is 4. What about this length here? This is the radius of my tiny semicircle. So this is my b. So we have b here. And what about this length here? Well, this is the radius of the largest semicircle from the center to the edge of this semicircle. This is my a. So let's find a squared minus b squared using the Pythagorean theorem here. First, we have to find the hypotenuse, which is always across the right angle. So this is the hypotenuse. And then the Pythagorean theorem says take one side, so the 4, and square it, plus take the other side and square it, so b squared. And then you get the hypotenuse squared, which is a squared then. Let's solve this equation for a squared minus b squared. We have 4 squared here, which is 16. Let's bring the b squared to the other side by subtracting b squared on both sides of the equation. Then we have the 16 here. This is 0. And on the other side, we have a squared minus b squared. A squared minus b squared is equal to 16. So let's go back to our formula here where we had a squared minus b squared in here. We've just found out that this is equal to 16. So we have pi times 16 over 2. And now we can reduce this fraction. 16 over 2 is equal to 8. So we have pi times 8 here, or if we switch these two, we have 8 pi, and this is our result for our area. I'm curious how you solve this problem, so please let me know in the comments. I wish you a wonderful day, and I hope to see you in one of my next videos. Take care!